the last but not the least unit that we are going to discuss is searching and sorting. Um, in most of the case, what happens, we have huge amount of data. You know that you know about the concept about data science, big data, right? So we have huge amount of data, and when actually we want to search a particular data in that huge data, it takes much more time. For example, I have 100 records, okay, and I want to find a particular data record in that 100 records, okay. So what basically we will be doing, example, I want to search a book for data structure, and here we have a library. In that library, some shelves are there, bookshelves, okay, and our data structure book is kept in one of these shelves, and no any information is available about this, that in which shelf the book is there, considering the fact that each shelf contains 50 books. We have some bookshelf, and capacity of each shelf is of 50 books, okay, and we want to search a textbooks of data structure. No any information is given about which shelf contains which year book, okay. So books are kept randomly, there is no any proper arrangement of the book. So you started searching for the book in, let's say, you selected shelf number 1, okay. um, you are here, so whichever is the first, you started searching in that. You searched all the 50 books, but you haven't found the book for data structure. Assuming that you took 20 minutes to see all these 50 books, okay. So no any result because the book is not here. Again 20 minutes for this 50 books. Then the book is here in this, and you took 10 minutes to search the particular book. So it's very tedious work, right? You have searched 50 plus 50 plus, assuming that 25th book was, or 26th book was the DS book. So you did 50 plus 50 plus 120. So that is 125 searches you did. And after that, you got the book. However, instead of this, if the shelves are arranged in such a way that on this shelf, the marking is done like all books with respect to FY is stored here, all books with respect to SY are stored here, then TY are here, then final year, let's say BTech are here, and MTech books are here, MTech. So what information you get from this arrangement? That the book for data structure is for, let's say, second year. So it will be in shelf number 2, right? Let's say shelf number 1, shelf number 2, shelf number 3, 4, and 5. So where is your book? In shelf number 2. Also, in this shelf 1, the books are arranged in alphabetical manner. That means from A, B, C books are here. Then D, E, F books are here. D, E, F, G, H. Okay. So what you get from this, that your book is in second level, is at second level because it is starting with D. And also you can easily go for, let's say, DA, data structure. So you can find DA, DA, DA. Okay. And then with a minimal effort, that means now you are not searching the shelf number 1, you are directly going in the shelf number 2. Also, you are not looking for, let's say, first 20 books, or let's say first 25, let's say 20 books, because they are let's say alphabetically ordered as A, B, and C. You are directly going in the level 2, in the bookshelf 2, right? You might be searching only 4 to 5 books to get the DS, assuming that you searched 5 books and after that you got book for DS. So how many searches you did in this case? Only 5 versus 125 that we did in the previous cases. And that makes the huge impact. What will happen in a searching when data is properly arranged? So here we are going to talk about the most important concepts in computer science, that is searching and sorting. When data is not properly arranged, then searching a particular item in a data set becomes very difficult. And searching is what? Searching is nothing but trying to locating or finding the required data in the database or data sets. Okay, so here we are going to talk about what is need of searching. Already I have discussed the need of searching. Okay, and if data we want to make faster search, then if data is properly sorted, it can be done very easily. So this is what we are going to now discuss, searching and sorting. So here we will be talking about sequential search, then binary search. We are going to talk about skips list. First, I will be talking about sequential search, then binary search, then insertion sort and selection sort, and then Reddick sort. And then we will be talking about skip list. Okay. And then we will talk about file handling. Fine. So let's begin with searching techniques. So why we need searching techniques? I just thought let's discuss with you. Computer systems stores large amount of data. Hence, searching is required for retrieval of individual records from the data sets. Thus, there is need for fast searching. Now, searching is done, let's say sequentially, let's say 1000 data is there. And my data is at 190, let's say 99th location. Total data elements are this much. 1, 2, up to this. Okay. And my data is at, assuming that is at this location, 199. Okay. So if I started sequentially searching, so I will searching element 1, element 2, then element 3. Searching a particular element, let's require 1 second. Okay. So here to reach to location 999, I might have to spend 999 seconds. Okay, so that is nothing but sequential search. So when I'm doing sequentially searching, time it takes to get the result, required result, is very large. So objective is to do searching faster, and for that purpose we have different algorithms. So what is meant by searching? Searching is the process of locating certain data from a given list, that is the searching. Searching example, telephone number from the contact list. So you might have done this, searching a telephone number in the contact list. Okay, so types of searching, there are two types of searching algorithms, linear search and binary search. Linear search is also called as sequential search. Okay, so now we are going to talk about linear search or sequential search. There might be question in examination, explain linear search or sequential search, or write a program for linear search or sequential search, or any particular list will be given to you and apply linear search algorithm, and in how many steps you will be getting the desired output. Okay, so what is meant by linear search? What linear search does, it traverses the array sequentially to locate the required element. So we traverse the array, whatever is given. See here, array element is given. So what we do, we sequentially traverse this array and we compare item to search with each and every element of the array. So it searches for an element by comparing it with each element of the array one by one. That's why it is called as sequential search. In linear search algorithm, that is applied when to apply linear search algorithm? When there is no information given about the array. No information means whether it is sorted or unsorted. Okay. If given array is unsorted or elements are unordered, we have to use the linear search. Information also not given, and when information is, let's say, available and we have the idea that elements are unsorted, we are going to use linear search. And also we are going to use linear search when data items or data set is smaller. If my data set contains millions of records, then in that case doing linear search is not a good idea, because in linear search we do searching one by one. It takes too much of time for searching. Okay, understood linear search? Now we will be talking about linear search algorithm. Now considering a linear array A of size n. So what array we have with us? We have A of n. This is my array. Okay. Now element to search is item. So let's say item, item is nothing but element to search. Item is compared with the first element. Now assuming that here A of n, we have some elements like 5, 3, 6, 2, 8, and item to search is equal to, for example, 6. Okay, so item is compared with the first element. So now we are going to compare 6 with 5. Is 6 equal to 5? No. That means if search ends in success. So is the success? No. Now we are not going to read this. okay, because it is fail. Else item compared with the next element. So search ends in fail, unsuccess. So item will be compared with the next element. So now 6 will be compared with 3. If search ends in success, no. Okay. So again, item will be compared with the next element. Now, if search ends in success, yes. So it sets a location lock variable. Lock is nothing but the location variable. Location variable to the index of the element. Otherwise, it sets location to -1. Now here, location value will be equal to let's say 1, 2, 3. So index is let's say 0, 1, 2. So location will be equal to 2. Location is equal to index of the element, that is 2. Okay. Now if I want to search item as 16, so whether 16 is equal to 5, no. Compare with next element, compare with next element, compare with next element, compare with next element. Now 16 is not present in the array, right? So process continues till successful search or end of the array. Now end of the array is reached and there is no match. That is, item is not matched with any of the element in the array. So here value of location will be -1. So we have, if the value of location is -1, element is not present in the list. And if location value is equal to in between any of the array index, that means at that location, the particular element is present. Okay. Now let's see the example. We have roll number and name, two-dimensional array is there. Okay. So numbers, roll number and name. Name you can say in, let's say, A, B, C, D, E. That is what randomly I have given. Okay. If we can use any name. Okay. MIT, Aurangabad, Jalna, Pune, these kind of the names. Okay. And roll numbers are, or you can say pin code. They are unsorted. Okay. Now here, our objective is to find item to search is 5. Okay. So item is equal to 5. First, is item is equal to element? Yes or no? Item is 5, element 1 is 4. So is they are same? No. So go to the next level. Is item is equal to element 2? Yes. So we will display the message that location is equal to 2. We will set location as equal to 2 and then we will print that value. That is, item is present at location 2. Okay. Understood this? Yes. Okay. Now the algorithm for linear search. For this linear search algorithm or function, pseudocode for this function, what we are going to do, we are going to pass the array, then size of the array, okay, then item to search and location. Initially, location value will be equal to -1. Initially, the value of location will be -1. Okay. Now, these 4 parameters we are passing to a linear search algorithm or let's say method. Now we will start, begin for I equal to 0 to n minus 1. N minus 1 means I equal to 0 to, let's say if we have number of elements 5, so it will go from 0 to 4. Okay. What we have to do, if a of I equal to item, so we have to just compare the array index element with the item. If they are same, then we will say location is equal to index of that element where actually that item is present. Okay. And then exit because search is successful. Okay. If after end of this for loop, we haven't got any element matching with the item, then the for loop will stop, for loop will exit, and then we will save the value of location to -1, indicating that element is not present in the list. Okay. Now I will show you a C program demo for linear search. Okay. So just give me 1 minute. Okay. I think I have shared with you only PDF, PPT, right? Is blue screen visible?
Yes, sir.
Okay. So now we will, yes. Okay, so now I will show you the program for this. Okay, I have written one method, L search, that is linear search. Okay, so in L search we are passing an array to search. Okay, then one more that is size. Okay, then one more parameter that is nothing but item to search, and one more parameter that is location value. Okay, so these four are nothing but the parameters that we are passing to the linear search method. Is this clear? Now the required data that we need to declare are array, size is 10, randomly I have taken 10 size, then item to search that we are going to accept in item, then I for loop, okay, looping variable, and for the size of my array, okay, and location is equal to -1. Initially I have initialized the value of location as -1, assuming that item is not present in the list. Whenever item is present in the list, we will replace the value of location with the value of the index. Okay, now here I'm giving message to user, that is input the number of elements %d comma address of n. Is this clear? Now input the numbers, 5 numbers, 10 numbers, so whatever number of elements user wants to accept, we will give message to user, please input that many numbers. Okay, and you know that we use for loop for accepting that number of elements. Okay, now input a number to search. We have accepted 3 inputs from user. What inputs we have accepted? Number 1, the number of elements. Number 2, that total number of elements. If user gives 5, then let's say for number of element 5, and for inputting that numbers, we are again accepting 5 elements. Okay, and then after that we are asking user to please enter number to search or element to search or item to search. Okay, and then we are passing these parameters to a function L search. Okay, and whatever that function is returning, we are accepting that value in location variable, LOC variable, location. Okay, now let me do line by line compilation, and let me do one more thing. Okay, in watch variable, I will add the variable, let's say item to search, and then we will add here array of I. So we will get when item and array will become same, we will get this message. Okay, and then LOC variable. Okay, so observe all these variables when our program starts execution. Also observe the output window. Okay, so what all things you need to observe, that is also I have told you. Okay, now CLR SCR, see output screen is clear now. It has given message input number of elements in array. So now we have to give input. So let's say I have given 5 as input. So let me do one thing. Let's have the value of n. So see here n is equal to 5. In watch variable, see n is equal to 5. Okay, now let's proceed. 5 elements we have to accept, so we are accepting the 5 elements now. I'm giving 5 elements all as now numbers are not sorted. Okay, so I'm giving unsorted list. So I need to give input again and again. Okay, okay, so input number to search. Now what number to search? For example, I want to search 2. Okay, so that is what I have given. Now what is location of 2? Don't start with the index, tell me the location. We are not going to say that 4 is 0th location, it is first element. So first, second, third and fourth, so it will be 4th. Okay, index is 3 but its location is 4. Okay, least when you are standing in a queue, we never say that you are standing at 0th position, we say that you are first student in the queue in the list, right? Okay, so input number to search, that is 2 I have given. Okay, So let me write here. See, now the item value is 2 in watch window. Okay. Now we will go to the function call. Okay. Now in function call, all values are passed. Now in for loop, now what is a of I? See here, a of I is equal to find. Now in find, what we have, let me write here, find, find. See, in find we have 2. Okay. Now the value of I and a of I. So okay, I should have one more variable, a of I. Okay. Now see, a of I is 7. A of I is 7. What is value of I? Let's have the value of I. I is equal to 1. That means first iteration is already over. Okay. Now we are going for second iteration. So a of I is 1. So a of 1 is 7. See here, a of 1 in output window, a of 1 is 7. Okay. So whether a of 1 is equal to find 2, 7 is equal to 2? No. So it will again increment the value of I. It will become now 2. See the value of I in watch window, 2. So a of 2 is what? See here in output window, see a of 3 is, sorry, a of I, a of 2 is 3. Okay. Now whether 3 is equal to 2? 3 is equal to 2? No, I will be incremented by 1. It will become now 3. I is equal to 3 now. Now a of I is equal to 2. A of 3 is 2. Okay. And find or the item to search is also 2. Match is got. So now L is equal to, let me write here one more variable as L, and now L will become equal to 3. So L is equal to 3. Got here, L equal to 3. Now I will be incremented by 1 again, and there is no any difference. Now return L is equal to 3. That is what we are going to return now. Okay. Now we will go back to our program, and value of location, see here, value of lock is set to 3. Now if lock equal to -1, no, we will go to the else part. So we will now in else part. So %d is present at location %d. Now see here what we are actually printing. Location plus 1 we are printing. Location is nothing but actual index value. Is this clear? Okay. So when we will print, let's say press F7, we will get output as 2 is present at location 4. Clear everyone? Linear search algorithm? Yes. Fine. So demo is over, and now we are going to understand next algorithm, that is binary search. Is linear search understood by everyone? Okay.